We're going to look at the fourth situation with permutations that we look at, and that is if we're arranging things not in a line but in a circle. And how does that change the situation? So it all comes down to the very first object that you end up placing. You see, if we've got a line, so here's an example of a line, then I've got a definite start and finish to the line. I know where the first spot is. I know where the second spot is, and so on and so on. So therefore, the first object I place has a choice of 6 spots that I could put it. Now when I have a circle, it changes. Because it's a circle, there is no definite starting point or finishing point. So I can't say, oh, that's position 1, that's position 2, and so on. So the first object actually only has one choice, and that is to be placed in a circle. Because it does not matter where I place it, because I could always rotate the circle and it would then be in a different spot. So the first object has a spot. Now once that first object's in there, now I can define the other places, because it might be the spot that's 1 to the right or 1 to the left or something like that. So therefore, the line will start off with N. We know that. With a circle, now instead of starting with N, we start with one possibility. We put it in the circle. But then after that, everything's the same. Second object has N minus 1 spot. Third object, N minus 2 spots. And so on until we get to the end. So effectively what happens is the number of arrangements for a circle, it's our n factorial, which is in a line, but we divide it by the number of ways we could have placed the first object. Well, n factorial divided by n is simply n minus 1 factorial. So effectively, we just take 1 off. So here's an example. We've got a meeting room, and as often happens when you have meetings, you sit around the table. And there's 10 chairs. Now, our committee of 10 people, which has 3 teenagers in it, how many arrangements are there in which all 3 of those teenagers sit together? All right, we'll first look after the restriction. The restriction is the 3 teenagers wish to sit together. So we get them together and go, okay, work out how you'd like to sit. 3 factorial ways of doing that. Now it'll be times 7 factorial. Why 7? Well, the 3 teenagers, it's now like they're one person. I've got 7 other people, so there's 8 people I'm arranging, but I'm arranging them in a circle, so it's 1 less. 7 factorial, not 8 factorial, and that gets us 30,240. Okay, we've got our committee, and this time they're not necessarily the teenagers together, they're just the committee sitting in a circle. But elections are held for the chairperson and secretary. What's the probability that they sit directly opposite each other? Okay. Well, bottom of the fraction would be number of ways, no restrictions. 10 people, but in a circle, 9 factorial would be the denominator. Okay, now with restrictions. Let's sit the president down. Oh, somehow the chairperson has just been promoted. They're now a president. Anyway, let's place the president in the circle. No one's in the circle yet, so none of the spots are defined. There's one way I can do that. Now I'm going to put the secretary in, but we've said the secretary has to be seated directly opposite. So there's only one way the secretary can sit. Now I have to put in the other 8 people, but it's 8 factorial. Because once I've put something in the circle, it's now treated like a line because I can define the positions. So I don't take 1 off. So it's times 8 factorial. So we get 1 times 1 times 8 factorial on 9 factorial, which is 1 on 9. Now here's the thing. Hang on a sec. If we think about this logically, the president's going to sit down, and of the 9 seats that are left over, there's only 1 seat that will be directly opposite them. Therefore, there's a 1 in 9 chance that the secretary sits opposite the president. So as I say there, sometimes simple logic will work it out a lot quicker. All right, HSC question. 7 people around the table. They start off with the basic question, I guess. How many arrangements are possible? Well, 7 people. We're putting them around the table. So that would be 6 factorial. Part 2. Well, there's 2 people, Kevin and Jill. They refuse to sit next to each other. How many seating arrangements are then possible? Well, it's a lot easier to work out how many ways they are together and take it away from the number of possibilities. So all right, if they are together, so Kevin and Jill are together, in their group. Okay, work out how you're going to sit. 2 factorial ways. Now we're going to place them in the circle along with the other, how many people we got all up? It was 7 all up. So the other 5 people, so we've got 6 people, but we're placing them in a circle. So it's 1 less, 5 factorial. And 240, but that's not what we want. We don't want the 240, we want the other arrangements where they're not together. Take it away from the 720, we end up with 480 possibilities. Okay, here's just a little flow chart that I found. Forget where I found it, but I thought it's not too bad. Sort of what your thought process is as you're attacking these questions. Because as I said yesterday, it's lovely when they're in a simple exercise and you know, oh, this is exercise on combinations. Oh, this is on permutations. But when you just come across a question, you've got to make those decisions yourself. So, all right, permutations and combinations question. Well, first of all, the perms and coms has to be without replacement. So as soon as the question is with replacement, you go back to the basic counting idea. Okay, but if it's without replacement, then you've got to ask yourself, well, do I have restrictions or don't I have restrictions? So you need to sort that out. And then you go, all right, is the order important? Well, if it's not important, then we're just talking about a combination question. So we deal with that. If it is important, we know it's a permutation. So the question now becomes, are we arranging in a line or are we arranging in a circle? So we make that decision. Now with the questions we see, we'll then go down, well, if it is in a line, sometimes we end up using all the objects. That would just be n factorial. Sometimes we only use some of the objects. Well, that's NPR. And then with the ones where all the items are used, we go, well, hang on, are they all different? Or are some of them the same? And then we had to divide by the number of ways they are the same. So that's sort of the procedure that you're sort of going through when you think about these questions. How will I attack this problem? So 14G will be our circle arrangements. Have a go at some of those.